Hi, today I'm going to talk about conversion between decimal numbers and binary numbers. So far we have all along been working with IPv4 address in decimal dotted notation form. Okay, as we understand that for human, we are much better to look at IP addresses in at decimal dotted notation, which is in the form such as 192.168.56.10. Okay, but when we talk about machines or network, when the devices actually communicate with each other, they are not actually interpreting the IP addresses in decimal dotted notation. In actual fact, machines, routers, switches, needs to actually look at all these addresses in terms of binary, in ones and zero, which is the language that they are using. So before we start off, let's talk a bit about IP addresses. As you can see, IP addresses basically consist of 4 decimal numbers in 4 separate sections. And we in the networking world, basically we call these 4 different octaves, OCTT. So octaves basically is in the same class as octopus, octagon, which means 8 legs or 8-sided. So basically it means that for IPv4 addresses, when we talk about 4 octave, every octave itself, actually, it consists of 8 bits. So it means that basically I will have 8 bits dot 8 bits dot 8 bits dot 8 bits when I'm referring to the 4 octave, which is the 4 decimals in the 4 separate sections, which basically give rise to a 32 bits number, which basically forms your IPv4 addresses. So how can we convert a decimal dotted notation, the decimal number, into a 8-bit binary number? This is where we are going to touch on today, and how to convert, if given a 8-bit binary number, how to convert it back to a decimal numbers. So let's go to this Excel sheet that I've created, and I'm going to explain a bit. So you can see that I have taken an example here. So basically a binary number is actually using a power of 2. So you can see from here, when we talk about decimal numbers, and we know that decimal number by now is actually equate to 8 different bit 1, 2, 3, 4, 5, 6, 7, 8. And in actual fact, these 8 different place, is corresponding to a value, which is to the power of 2. So the least significant place, is actually having a value of 1. The second one is 2, 4, 8, 16, 32, 64, and 128, which give rise to the 8-bit values that goes into the decimal number. And how do we get this 1, 2, 4, 8, 16, 32, 64, and 128? Basically, is 2 to the power of 0 for the least significant bit, that's why it's 1. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 32, 2 to the power of 6 64, and 2 to the power of 7 is 128. So in actual fact, if you really need to convert between decimal to binary or binary decimal, the most important thing to remember is these 8 different values that is associated with the bit number. So when we need to convert a decimal number to its binary form, basically we will actually need to look at what is the value that I can deduct from the decimal number that I'm given with, starting from the highest value. So we know that 192 is bigger than 128. That is the reason why, I can actually subtract 128 from 192 to get a remainder. So whenever I can subtract a value from the decimal number that I'm given, I will actually put a value of 1, in that significant place. And when 192 minus 128, I'll be getting 64. When I look at the next value is 64, okay, I can still minus 64 from the subtraction of the value. Okay, so I will give the next placeholder another value of 1. Okay, and when 64 minus 64, I will get a 0. It means that I won't be able to subtract any more value from the number itself. That will mean that the rest of the place, the 32 value place, 16 value place, 8 value place, 4, 2, and 1 will be having a value of 0. So basically this will actually give me the binary equivalent of the decimal number 192. So decimal 192 will be equals to binary number 11000000. Okay, let's do another example for 201. Okay, so if you are given a decimal value of 201, okay, so similar process. Okay, I will put a 201 here. Okay, and I will try to see I can mine. And when I look at the most significant value, basically is 128. So I know that I can minus 128 from 201. So I'll place a value of 1 here. Okay, so 201 minus 128, I'll be getting 73. Okay, oops, sorry, 128. Okay, I'll be getting 73. Yes, 73. Okay, so I look at the next value, 64, and I know that I can subtract 64 from 73. Okay, so I'm going to put 64 here, and I'm going to ensure that I put a value 1 in the second placeholder again. Okay, and 73 minus 64, I will be getting 9. Okay, 9, yes, 9. Okay, 9, yeah, 9. Okay, so a remainder of 9. Okay, when I look at the value of 32, I cannot minus 32 from 9, so I'll be giving a value of 0. I cannot minus 16, I'll be giving a value of 0. I can minus 8, so I'll be giving a value of 1. Okay, so I'll be minusing 1 now. Okay, 8. Okay, so I'll be getting a remainder of 1. Okay, so I cannot minus 4 from 1, so it'll be 0. I can minus 2 from 1, will be 0. But I can minus 1 from 1, so I'll be giving a 1. Okay, and basically, I'll be getting final value with 0. So that means that a decimal value of 201 will be equivalent to a binary number of 11001001. Okay, so basically this is how you can convert decimal to binary. Okay, and what about conversion from binary to decimal? If you are given a binary number, okay, that is actually much more easier compared to the conversion between decimal to binary. So take an example here. Okay, we still need to refer to our 8 value when we convert between decimal and binary, because similarly, by looking at the binary value, every place, when you look at the binary number, every place that have a value of 1, it means that I will need to add the value that is been assigned to that specific place. Okay, so take example, a binary number of 01101. Okay, so it means that in every place that have a value of 1, I will actually need to add in that specific place value. So I know that the second place have a value of 64, the third place 32, fifth place 8, and the last place 1. So basically when I need to convert this binary back to its decimal number, basically by identify all the value that have a binary bit of 1, I just add up all the value. So you can see the calculation is here, 64 plus 32 plus 8 plus 1, which will give me a decimal number of 105. Okay, so that is how easy it is to convert from binary to decimal number. Let's look at another example. So we can see that given a binary number of 100000111, in order to get the decimal value, I need to actually identify all the bits that have a value of 1, and basically to make sure that I fill in okay, the decimal equivalent value for that specific bit value. So I can see that I will have 128, I'll have 4, I'll have a 2, and I will have a 1. So the working will be 128 plus 4 plus 2 plus 1, okay, which will give me, okay, 130, 135. 135, yes, 135, okay. So that means that a binary number of 100000111 will be equivalent to a decimal value of 135, okay. And basically this is how you convert between binary to decimal, okay. And the most important thing to remember when you need to convert between, okay, decimal to binary or binary to decimal, okay, this 8 number, okay, basically is a must for you to actually remember.